Hi dear student friends, so myself Manjunatha PC, Senior Assistant Professor, Department of Computer Science and Engineering, Reva Institute of Technology and Management, Yelahanka, Bangalore. So in continuation to my previous sessions, I would like to take you on the concept of functions, arrays and strings. Before we proceed, so let us see what we have discussed in the previous session. So in the last session, we have learned the bubble sort program, then the modification of the bubble sort to improve the efficiency of the bubble sort, so that is to avoid certain redundant comparisons. So when not necessary that in the bubble sort we have to go through all the n-1 passes to sort the elements. So in between only, if the elements get sorted, then we can avoid going to the rest of the passes. So that's what we have seen in the modification of the bubble sort. So next we have seen the introduction to two-dimensional arrays. So there we have seen the how to declare a two-dimensional array, then how to initialize the two-dimensional arrays. So along with that, we also have seen, so while using the two-dimensional arrays, what are the necessary measures we must take or we must keep in mind, so while using the two-dimensional arrays. And later we have seen, so how to refer to the elements of the two-dimensional array, the way we have referred to the elements of one-dimensional array. So similarly, how we can refer to the two-dimensional array elements we have seen in the previous session. So in the today's class, so we will be learning again revisiting the two-dimensional arrays, because it is prerequisite to continue with the next consecutive concepts involved in the two-dimensional arrays. And after that, so we will see the simple programs and two-dimensional arrays, then followed by a program to read and print a matrix, and then we will see the program to compute the transpose of a matrix. And so later we will see the row major and column major orders, which are used in whenever we are reading the array elements. So basically the matrix elements. Then finally we see a program to read a matrix in row major and the column major orders. So in the last lesson, we have seen the concepts of two-dimensional arrays. So here let us revisit the concept of two-dimensional arrays. So consider the declaration int a of 4. So here we see that, so a is an array of 4 integer elements. So that is, so here we get a of 0, a of 1, a of 2, a of 3. So what we can note here, like, so all the elements are stored in a contiguous memory area. If it is 16-bit machine, and if the elements are taking 2 bytes of memory area, then a of 0 will take 2 bytes, a of 1 also will take 2 bytes, a of 2, a of 3 all will take the equal number of bytes. So altogether, so since we have 4 elements here, the 8 bytes of memory will be arranged so in a sequential order. So here the memory is allocated in a contiguous locations. So thus we can say, like, one-dimensional array is an array of individual elements of same type stored in a continuous memory area, right? So now when you come to the two-dimensional arrays, so the declaration is like int a of 2, 4. So here we have seen, like, so a is the name of the array, the int is the data type, 2 is the size of the row, and 4 is the size of the column. Here we have 2 rows and each row is having 4 elements. So here we see, like, so a of 0, 0, a of 0, 1, a of 0, 2, a of 0, 3 are the 4 elements of the 0th row, immediately followed by, so a of 1, 0, a of 1, 1, a of 1, 2, a of 1, 3, which are the 4 elements of the second row. From the program point of view, a of 1 is the second row and a of 0 is the first row. So here we can see, like, one after the other the rows get allocated. So here we can see, like, each element are again in the continuous memory locations. A of 0, 0, so immediate next 2 bytes will be for a of 0, 1, immediate next 2 bytes for allocated for a of 0, 2, again immediately the next 2 bytes will be allocated for a of 0, 3, and so on. So immediately after the end of the 0th row, the first row elements will get the continuous memory location. Now so look at the another declaration, so a of 3, 4. So here we have 3 rows and 4 columns. So here a of 0, 0, so that is the first element of the 0th row, then followed by a of 0, 1, a of 0, 2, so this is a of 0, 0, followed by a of 0, 1, followed by a of 0, 2, followed by a of 0, 0, followed by a of 0, 1. So here it will be like a of 0, 2, followed by a of 0, 3, the 4 elements of the 0th row. So number of rows is 3 here, whereas number of columns is 4. So like each row will be having 4 elements, 0, 0, 0, 1, 0, 2, 0, 3. Immediately the 0th row is followed by the elements of the first row. So here we start with the index here 1. So here when the first index is 0 here, it means it is a 0th row elements. When the first index is 1 here, this is the first row elements. Again here we have the 4 columns, so that is 4 elements, a of 1, 0, a of 1, 1, a of 1, 2, and a of 1, 3. Similarly it will be followed by the second row. So that is, so a of 0 is the first row, a of 1 is the second row, a of 2 is the third row. Since we have mentioned here 3 rows, here the 3 rows will be in adjacent memory locations. This is a of 2, 0, followed by a of 2, 1, a of 2, 2, and a of 2, 3. Now so here we can see, like, so in case of two-dimensional arrays, it is an array of one-dimensional arrays stored in a continuous memory area. So you can see, like, 0th array what is there, So following the 0th array we have the first array, and following the first row of elements we have the second row of elements, and so on. So that is all the rows will be stored in a continuous memory area, and within the row, so since each row is one dimensional array, again the elements of the row will be in a continuous memory location. So is the reason we can define a two dimensional array as array of one dimensional arrays stored in a continuous memory area. So now we have seen that syntax of declaring the two dimensional array. So that is, we have to mention the data type followed by the name of the array, followed by the row size, and followed by the column size. So here we are mentioning the two subscript here. So this is a one subscript and this is the another subscript. If you are mentioning only one subscript, then that will be like a one dimensional array, and if I am using the two subscript, then that becomes a two dimensional array. Since it is a two subscript which is used in a two dimensional array, sometimes we say like it is a double subscripted. When it is single subscript, it is a one dimensional array, and whenever it is a double subscripted, it will be a two dimensional array. And when you come to the an example problem, so here int a of 3 4, here we have 3 rows and 4 columns. So this a is a two dimensional array of 3 rows and 4 columns. So here, so altogether 3 into 4, 12 elements will be having the maximum. Since the index starts from 0, so the first index will go from 0 to 2, because here the value mentioned the row size as 3, here it will go from a of 0, a of 1, a of 2, and since the column number of columns mentioned here as 4, the column size is 4, this index will run from a of 0 to 3. So altogether we have in the each row 4 elements will be there. So we can see like a of 0 0, a of 0 1, a of 0 2, a of 0 3. This is the row 0. So this is the row 1, this is the row 2. Similarly in each row we have 4 elements. So column 0, column 1, column 2, column 3. Though in the memory, so it is stored in a contiguous memory area, but externally we can visualize this as a matrix. So here a is the name of the array. So first subscript is the row subscript, the second subscript is the column subscript. So we can say like this particular two dimensional arrays simulate the concept of the matrices of order m cross n, because we are using here only the rows and columns. We have m number of rows and n number of columns based on the size of the two dimensional array we specified there. So is the reason two-day array simulate a matrix of order m cross n. Now, so consider how exactly the elements of the two-dimensional array are initialized. The 2D arrays are initialized row wise. Now, you see here a of 2 3 is a two-dimensional array having 2 rows and 3 columns. The first 0th row is having 3 elements, and again the first row will be having the 3 elements over there. So here each row is one dimensional array, and we know that how to declare a how to initialize the one dimensional arrays. Within the curly braces we separate the elements by comma except the last element of the array. So here also same way, the 0th row is one array, so this is initialized with the 17 12 and 35. So here in the 0th row, 0th column is 17, in the 0th row first column is 12, in the 0th row second column is 35. So altogether 3 elements of the 0th row are mentioned here, and similarly it is followed by the elements of the second row. Again in the second row, so the index will be 1 here, so 14 is the first row and the 0th column element. You can see like a of 1 0 is 14, similarly a of 1 1 is 55, and similarly a of 1 2 is 67. So thus in the memory, so these arrays will be stored in a contiguous memory area. So these are the addresses of the 0th row, and these are the addresses of the first row. So within the rows, each elements are in a contiguous memory location, because each row is one dimensional array, and the two dimensional array is an array of one dimensional arrays. So this is one row, this is another row. You can see like the address start from 3600 and go up to 3611. The starting address for the last 2 bytes of the integer is 3610. So altogether here 3600 to 3611 means 12 bytes of memory will be allocated. So here number of elements is the size we have mentioned as 2 rows and 3 columns, 6 elements are there. So each integer will take 2 bytes of memory area. So we can assume like in the 16-bit machine we have allocation of 12 bytes memory area for this particular two-dimensional array. Now, so if you look at the another initialization here, a of 2 3 here. So again here we have 2 rows and the 3 columns. So altogether we may expect here 6 elements, but here we have mentioned 1 2 3 4 5, only 5 elements. So here what happens is the elements are initialized row wise. So the 17 12 35 considered to be as the elements of the 0th row, and remaining elements will be considered the elements of the first row, and so on. So here, so a of 0 0 is 17, 0 1 is 12, 0 2 is 35. So then the next element will go to the first element of this first row. So, that is A of 10 is 14, then A of 11 is 55. The next the elements are not there. So, since it is partially initialized, remaining elements will take the value as a 0 there. So, here the first row second column element, that is the last element of the second row from the end user point of view, it is taken as a 0 here. Now, consider the another initialization A of 2 3. Here we have 2 rows and 3 columns. Here the elements are initialized with the row wise. Here it is not initialized row wise, but internally it will take the elements row wise only. Now, in this particular case what happens is each row must have the 3 elements, but I am mentioning only 17 and 12, the 2 elements of the first row and only one element of the second row. So, here the remaining elements will get the default value as 0. Here also the remaining elements will get the default value as 0 because they are partially initialized 2-dimensional arrays. Here A of 0 0 will be 17, 0 1 will be 12, and the third element is not there, not mentioned here in the initialization. So, it will take the value as a 0. So, 0th row second column element will be 0. Similarly, in case of the second row, A of 10 will be taken as 14. So, in the second row the subscript is 1, the row subscript and the column subscript is 0 for the first element of the second row, and remaining 2 elements are not mentioned here. So, they will take the values as zeros by default. So, thus, so here we can see like uninitialized array elements will take the initial value as a 0. Now, we have seen like in the one-dimensional arrays, when we are initializing the array elements at the time of declaration, it is not mandate that I should mention the size here. The reason is since we are mentioning the number of elements here itself, so based on the number of elements mentioned, the size of the array will be computed. So, here we can see like 17, 12, 35, 14, 55. So, altogether the 5 elements I am mentioning there. Since I am mentioning the 5 elements, each integer will take 2 bytes of memory area. So, 10 bytes of memory will be allocated and the size of the array one-dimensional array is computed as 5. So, here it is not a mandate that I should mention the size of the array. It is not that it is applicable only when we are initializing the arrays at the time of their declaration. But just like that, without the size of an array, we cannot declare. In case if we are initializing the arrays at the time of their declaration, only then we have the option of omitting the size of the arrays there. So, because it will be computed automatically. Similarly, it is applicable even in case of the 2-dimensional arrays. Now, so you look at these particular declarations along with the initialization. So, in the first case I am mentioning here that I am not mentioning the row size, whereas column size I am mentioning it as 2. It means like here I have some n number of rows and each row will be having 2 elements. Fine. So, here I am initializing with the 1, 2, 3, 4, 5, the 5 elements of the array. Since each row will be having 2 elements, so 11 and 2 correspond to the first row, 3 and 4 correspond to the second row, and 5 and remaining element will be correspond to the third row. Since I am mentioning only 5 elements here, so here we compute that row size of this particular declaration will be 3. So, that is, so A of 0 0 will be 11, A of 0 1 will be 2, then followed by A of 1 0 will be 3, followed by A of 1 1 will be 4, and followed by A of 2 0 will be 5, and 2 1 it is not mentioned, it will take the value as a 0. See here column size is compulsory here. If we doesn't know the column size here, we cannot judge in each row how many elements has to be there. So, this is the guiding rule here. Once we define the column size here, so row size is not necessary here, because based on the number of elements provided, we can compute the row size. Since each row will be having 2 elements there, so here if we divide the number of elements by 2, based on that we define the row size, and this is how internally the row size will be computed by the compiler. Now, you look at the second declaration here, int A of row subscript I am not mentioning, column subscript is 4, and I am mentioning the 5 elements again. So, here this says that each row will be having 4 elements. It means like 11, 2, 3, 4 are the elements of the first row, and the second row I have only 1 element. So, means with respect to the 5 elements I can have only the 2 rows here. So, thus the row size of this particular declaration will be computed internally as a 2. So, this is 0 0, 0 1, 0 2, 0 3. These are the index of the first 4 elements of the 0th row. Then 1 0 is the index of the first element of the second row, and remaining elements, that is, so like 1 1, 1 2, 1 3 index elements will get the default value as a 0, because these are partially initialized. Now, look at this particular declaration. So, here I am mentioning here the column size as 5 here. So, the number of elements I am mentioning here is 1 2 3 4 5. Fine. So, each of these particular elements constitute the elements of the 0th row, and I am not mentioning the remaining elements, that is the elements of the second row, since I have provided only 5 elements here. So, these will be acting as the elements of the 0th row of the 2-dimensional array. So, here the row size will be taken as a 1. So, the row size must be a non-zero integer value, and also column size should be a non-zero integer value. The size of an array cannot be 0. Now, so in this particular case, I am mentioning the column size as 8, but here number of elements I am providing is only 5. So, thus it will treat the row size as 1, and in the row, so we have only 5 elements there, the remaining elements will take the default value as a 0. So, in this particular case, so 0 0 index is 11, 0 1 index is 2, 0 2 index is 3, 0 3 index is 4, 0 4 index is 5. So, the value and remaining elements will take the default value as a 0. So, we can conclude here like the row size may be omitted. So, once if you are initializing the 2-dimensional arrays at the time of the declaration, but column size is compulsory. The column is the guiding rule based on which we can conclude the size of the row size of the 2-dimensional array. So, thus we say like in 2-dimensional arrays row size is optional, but column size is compulsory. So, during the initializing 2-dimensional arrays at the time of their declaration, but I am not initializing, just declaring means I should mention the row size as well as the column size. But if I am initializing the 2-dimensional array elements at the time of the declaration, then row size may be omitted, but the column size is a compulsory. Now, so look at the accessing of the 1-dimensional array elements. So, if it is x of 3, we say like x of 0 is 17, x of 1 is 34, x of 2 is 53. This is the way how exactly, so we can access the individual elements of the array explicitly. So, sometimes if you want to read the elements, so values for the array elements from the keyboard, then we have used the scanf statement like scanf %d ampersand x of 0 provides the address of the 0th element, address of the first element, address of the second element. So, likewise we provide the address, read the element values for the array elements x of 0, x of 1, x of 2 in this context. Similarly, so if you want to print the data, then we can access the same elements, but here we do not use the address because we are printing the data there. Here we are reading the data into the memory location, so we must specify the address, that is ampersand symbol here. So, here ampersand is not necessary. So, thus we can say like in case of 1-dimensional arrays, x of 5 refers to ith element of a 1-dimensional array. Now, similarly, if you look at the 2-dimensional arrays, so here individually we can access each of these elements. Here we have 3 rows and 4 columns. So, the array index will run from 0, 1, 2 and the column index will run from 0, 1, 2, 3. So, here the first element is a of 0, 0 which is 17 and 0, 1 is the second element of the first 0th row, and the 0, 2 is the third element of the 0th row, 0, 3 is the last element of the 0th row. Similarly, we have first row and second row, altogether we have 3 rows, and the last element will be like a of 2, 3. Here we have 3 rows. So, a of 2 means that is the last row and the last column is a of 3. So, a of 2, 3 is 67. So, likewise individually we can assign the values explicitly, and here also if you want to read the elements of the 2-dimensional array from the scanf statements or from the keyboard, so then we can use the statement like scanf %d ampersand a of 0, 0. Here we are providing the address of the 0th row 0 element, 0th column element. Then to read the next element of the 0th row, we have to specify ampersand of a of 0, 1, 0th row first column. Similarly, we have to provide the address of the next element for the next element, ampersand of a of 0th row and then second column and so on up to the last element. The index is 2 and 3, so that is scanf %d ampersand of a of 2, 3. Similarly, when you are printing the data like this, then we have to use the same subscripts. Fine, we are using double subscripted here because they are 2-dimensional arrays. So, 0th row 0th column, and finally we have to mention here the second row third column. The value 67 we are going to print with this, and with this we will be printing the value 17. Similarly, we can print remaining elements of the 2-dimensional array. Thus, we can say here like whenever we refer to a of ij, so here it refers to ith row and jth column element of the 2-dimensional array. The first subscript will specify which particular row we are trying to access, and the second subscript will specify in the ith row which particular column you are trying to access. So, a of ij means the ith row and jth column element will be printed there. Now, having this particular idea, so let us write certain programs on 2-dimensional arrays. To read the program, to read and print the 2-dimensional arrays here, first we have to declare the 2-dimensional array, and we know the statement like, so in the previous case we have seen like, so this is the declaration of the 2-dimensional array with the mentioning of the row size as well as the column size. Now, so look at this particular program. So here I am mentioning the row size as 2 and column size as 3 here. So thus the number of rows possible here is 2. So whereas here number of columns possible is 3, and here altogether 2 into 3, 6 elements are present in this particular 2-dimensional array. So here I make a printf statement like enter 6 elements of the matrix. There exist 6 elements. So here we are asking for the 6 elements of the matrix. Here I am providing here 6 percentage Ds, 1, 2, 3, 4, 5, 6 for each of the elements of the matrix. Here I provide the address of the 0th row, 0th column element. Here I provide the address of 0th row and first column element. Similarly, here I provide 0th row second column element, and similarly we take the elements of the second row also, that is A of 1 0, address of A of 1 1, address of A of 1 2. Similarly, when I am printing the array elements here, the 6 elements of the matrix are here I provide the 6 elements of the 6 percentage D, the format specifiers to print the integer elements, and these 6 percentage D are the placeholders for values of A of 0 0, A of 0 1, A of 0 2, A of 1 0, A of 1 1, A of 1 2. So likewise I will be printing the elements of the matrix. But what if the order of this particular matrix is something like 10 cross 10? In case if it is like a 10 cross 10 matrix. So if it is 10 cross 10 matrix, then the number of elements that are possible there will be 100. So then 100 times I supposed to write here the percentage D, and to read the elements, similarly 100 times I supposed to type here percentage D to print the elements of the matrix. But this is not the recommended way of writing the program, because here we have to go on typing the program only. So here this way of reading or printing a 2-dimensional array is not easy and not recommended. So see, for the 2 cross 3 we have used 6 percentage Ds to read the elements and print the elements. In case if it is 10 cross 10, we may require here 100 percentage Ds. So is the reason. So this is not the method of recommended method of using the matrices. Now, so to use the matrices, here we make use of the looping constructor. When you go for the looping construct, you can see the code something like this. So here A of 2 3, here we have mentioned the same 2 rows and the 3 columns, altogether 6 elements will be there, and this particular row is important. So in this particular statement, so you see like this particular row correspond to the row, and this particular loop correspond to the j. So that is I loop will correspond to the rows, whereas j loop will correspond to the column. When I is equal to 0, the j loop will run from 0 to 3, because each row will be having the 3 elements. So the j will run from 0, 1 and 2. When I is 0, j is 0, I will be accessing the element A of 0 0. So I will be reading the value of A of 0 0. Now the j will increment and j becomes 1. So I will be reading here A of 0 1, that is second element of the 0th row. Now when j is further incremented, j becomes 2, I will be reading A of 0 2, that is the third element of the 0th row. So likewise, so I using the looping construct, I can read the elements of the matrix here, even if the array size is here 10 cross 10. So I will be having 100 elements there. So even for that I can mention just the I less than 10 here and j less than 10. Using the only one scanf statement, I will be reading all the elements of this particular matrix. So this is the way how we can simplify the things. Instead of typing 100 times the percentage D, I can mention only one time here by having the looping construct there. For every iteration of I loop, the j will run. So that is when I is equal to 0, 0th element row elements will be read. When I is equal to 1, first row element will be read, and when I is equal to 2, the second row elements will be read, and so on. But in this particular case, I will run only from 0 to 1 and j will run from 0, 1 and 2. And you can see here I am enclosing this within the opening and closing flower braces, but it is not necessary here, because for every iteration of I loop, j will run. Again j is a looping construct, and every iteration of j loop, the scanf will run. So here within this loop I have only one single statement. Not necessary that I should mention here opening and closing flower brace, but here for every iteration of I loop, since j is running here, so I have only one statement logically under this particular I loop. So it is not mandate that I should put here opening and closing flower braces. Even if we have opening and closing flower braces, still the program will work correctly. So but it seems to be like we have the multiple multiple statements within the loop, but logical here for every iteration of while loop we have a j loop statement, and for every iteration of j we have the scanf statements. So not necessary that I should have here opening and closing flower brushes. So this is the way how I am reading the elements of the matrix. Now to print the 6 elements of the matrix, like I is equal to 0, I less than 2, I plus plus, I can use the same statement, and here instead of ampersand will print the address. Here we have to mention the address, here just we are printing the elements of the some matrices. This is the way how I can use the looping construct to read and print the matrices. Now let's see a program to read and print an m cross n matrix. So what are the necessary the initialization declarations we are supposed to do? So in case of reading a matrix of order m cross n, so first you should know what is m and n. So after knowing that, we have to declare a 2-dimensional array to hold the elements of this m cross n matrix. In case if the order of the matrix is m cross n, then there will be m into n number of elements. Since I will be using the looping construct, I must take the 2 iterators I and j, and you can notice like in case of 1-dimensional array we use only one loop, because we have the single subscript. In case of 2-dimensional we use 2 loops, that is nested for loops or nested while loop, whichever the looping construct is feasible, we can use that. So based on the programmer convenience, here we feel comfortable with the loop for looping construct, we will be using that. So here for every iteration of I j will run, since we have the 2 subscript, 2 loops we will be using a nested for loop. If you are using only one loop, that is a single subscripted, in that case we are using 1-dimensional array. When we are using the 2-dimensional arrays, we must use the looping construct, that is so nested looping construct. So I is equal to 0 correspond to the row and j correspond to the column there. Now to program to read and print the matrix, here we must say like say m and n, the order of the matrix, 2 elements, 2 variables need to be declared, and for arrays, 2-dimensional arrays, one 2-dimensional array has to be declared, and for the loop iterators I and j has to be declared. So this is the program, so wherein we have done the declarations and we are reading the order of the matrix m and n value, m specifies the row and n specifies the column here. Now for I is equal to 0, I less than m, I plus plus, j is equal to 0, j less than n, j plus plus, I will be reading all the elements of the matrix. If it is a 5 cross 5 matrix, then so 25 elements I will be reading with respect to this particular scanf statement. And when you are mentioning the row and the column size here, we have to make sure that since the array is declared as a 10 cross 10, 10 is the row size, 10 is the column size, the m and n value cannot be greater than 10 value. Fine. So the number of rows and number of columns should be less than or equal to 10. So maximum I can read here 100 elements, because so 10 into 10 means 100 elements are possible. If it is a 16-bit machine, 100 into 2, the 200 bytes of memory is reserved. So out of which, so I have to utilize the memory. So if I am increasing the size of the matrix, order of the matrix as greater than the 10, then I don't have the memory space to read that. So I should make sure that the m and n value should be less than or equal to 10 here. Now, so with this I will be reading the elements of the matrix. Now to print this particular matrix, now I should use the same statement, except that here I should use the printf, and here so I should not mention the address. Address I mention here only to read, and to print I just like that I can print the elements of the matrix. So thus a of I j is sufficient. Ith row and jth column element of the matrix 2-dimensional array A I supposed to print over there. Now so with respect to this, so here we have the code, so where the percentage d elements of the matrix are, so m into n I will mention here. So with respect to this, so if I am mentioning 2 cross 3, then 2 into 3, 6 will be printed here. The 6 elements of the matrix are will be that message what is displayed over there. Then after that, for I is equal to 0, I less than m, I plus plus, again I access the column elements, that is jth row, using the jth row. Using ith row, I will be accessing the ith row using the looping construct. When j is equal to 0, I will be accessing the 0th column, j is equal to 1, I will be accessing the first column of the 0th row, and so on. So until I complete all the rows of the matrix, I will be printing here the each and every element there. Now so this is the way how I can read and print a matrix. But if you look at this particular program, when it is executed, the kind of output what we get here is something like this. Enter the order of the matrix. Assume I am entering here 2 and 3. 2 is the row size and 3 is the column size. Altogether 3 into 2, 6 elements will be present in the matrix. Since we have the 6 elements present in the matrix, so here enter 6 elements of the matrix. I am asking for the 6 elements of the matrix. So, that is 22, 7, 4, 84, 5, 13. So, altogether 6 elements I am entering there. Now, in order to display the matrix elements back on the screen, I am using the printf statement. The 6 elements of the matrix are 22, 7, 4, all the elements I am going to print there, because this particular printf statement correspond to printing of the elements of the matrix. But how exactly the matrix looks like? So, with respect to this particular input, whereas 2 rows and 3 columns, I have, so in each row I have 3 elements 22, 7, 4, and in the second row I have 84, 5 and 13. So, look at this particular. So, in this particular input, since the order of the matrix is 2 cross 3, we have 2 rows and 3 columns. So, in the first row we have 22, then we have a 7 and 4, and in the next row we have 84, 5 and 13. So, this is the order of the matrix. We have, so 2 rows and the 3 columns. So, now, so here this is the 0th row elements, this is the first row elements. Now, if I am displaying like a normal list of elements, then that cannot be a recommended one, because the matrix should be displayed in the form of the matrix only. So, whenever we are trying to display the matrix as a matrix, that will be more interactive one. So, we have to display the matrix in the form of the matrix. Now, so let us look into the same program just to display the matrix in the form of the matrix. So, this reading of the matrix element remains the same. There is no change in that. Even if we are entering the elements in the form of the matrix, providing the /n and /t and all those stuff, but still we are reading the elements serially, that will be stored in the memory area. But when we are displaying the elements, we can make use of the format specifiers or the /n, /t and all those particular escape sequences in a proper way to make sure that the elements of the matrix will be displayed in a proper way. Now, so look at this particular statement there. This is similar to the previous program statement, except that I am introducing here the one printf statement wherein I will be mentioning /n /t, and this particular /n /t, so I will be executing every time I enter to the new row that is to be printed over there. Now, I have the multiple statements. This has to be enclosed within the flower brace. Within the I loop, I have one printf statement. Again, I have the j loop statement there. So, when I is equal to 0, so I will enter to this particular block, and here I will go for the next line and then a tab space, then I print all the elements of that particular 0th row. Again, so when I is incremented, I becomes 1, I will be going to the first row. Again, when I am going for the first row, again I will go for the new line, and again I will take a tab space, the elements of the first row will be printed. Again, when I is incremented, I go for the next row, and before I go for the next row, again I take the /n /t, wherein I will be going for the next line, and again I will take the tab space and I will be printing there all the elements of the respective row there. So, before I enter to a particular row elements, so I should take the a next line there, so that the elements can be printed in the form of the matrix. Now, so here this code, when it is executed, so we can see like, if I am entering 2 and 3, the same element 22, 7, 4, 84, 5 and 13 are the inputs given, then the 6 elements of the matrix are 22, 7, 4, 84, 5 and 13. So, in the form of the matrix, the elements get displayed there. This is a recommended way of displaying the output of the programs related to matrices. Now, so look at another program. So, program to print the transpose of m cross n matrix. So, how to compute the transpose of a matrix? We know that we studied in mathematics, the transpose of a matrix means the interchanging of the row elements and the column elements. If I take the row elements as column elements and the column elements as the row elements, that becomes the transpose of the matrix. Now, so thus change the elements of the rows to columns and columns to rows will give you the transpose of a matrix. So, consider an example. So, wherein I have 3 rows and 4 columns. So, this is a 3 cross 4 matrix, and when you are computing the transpose here, the elements of the row 0th row 45, 67, 22, 55 will be acting as the elements of the column. So, that is, so the transpose of this particular matrix will be like, so the 45, 67, 22, 55, the row elements what were there, so they will be acting as the column elements here, and 0th row becomes a 0th column, and here the first row will become the first column, and the second row will become the second column. Thus, the size order of the matrix is also reversed here. So, here it is a 3 cross 4, now it has become here 4 cross 3. So, now we are supposed to read a matrix, and you have to print the original matrix as well as the transpose of the matrix. After transposing, what elements we are supposed to display, so that has to be done by this particular program. Now, so let us write a program for this. Now, to read the matrix here, or the normal procedure we can use. So, having declared here an array of 10 cross 10, m and n are the order of the matrices. So, here m specifies the row, n specifies the column, and here with this I will be reading the elements of the matrix. Now, the question is to print the original matrix followed by the transpose of the matrix, how it is to be done. Now, when you are storing the elements here, it will be stored in a consecutive memory locations only, starting from, so here if these are the elements there, first element 45, 67, 22, 55 will be stored, immediately followed by 13, 87, 51, 94, immediately further followed by 62, 33, 77, 72. This is the way how exactly it is getting stored in the memory. But when I am printing here, so this printing will says that this is the normal original matrix, and this way if I am printing, so this will say that this is the transpose of a matrix. Now, so this is the way how I am going to read the elements of the matrix. And now, so to print the original matrix, I can use the same looping construct, I is equal to 0, I less than m I plus plus, j is equal to 0, j less than n j plus plus. Here I am printing the elements of a of ij. When I is equal to 0, 0th row elements will be printed. When I is equal to 1, first row elements will be printed. When I is equal to 2, the second row elements will be printed, and so on. So, I will be printing all the elements of the matrix. Now, so consider the same input here 45, 67, 22, 55. So, this is the way of output what I get when I am printing the elements in the original matrix. But when I consider the transpose of the matrix here, so in the transpose what exactly printed is 45, 13, 62 and 67, 87, 33 and 22, 51, 77, followed by in the last row we have 55, 94 and 72. Now, look at this particular input and the index of these particular elements. Now, here if I take the elements of 45, then followed by 67, then 22 and then 55, then the next row elements are the 13, 87 and then 51 and 94, and the next row elements are 62, then 33, 77 and then 72. Now, when this is the 0th row, this is the first row and this is the second row, and this is the 0th column, this is the first column, this is the second column, and this is the third column. And when the transpose we are trying to get here, the elements what we get here is, so 45, 67, 22 and 55, and here what we get is 13, 87, 51, 94. And here the last column what we get is 62, 33, 77, 72. And when we are displaying the elements, we display in the row wise. What is the index of 45 here? It is the 0th row, 0th index. And what is the index of 13? So, it is first row and the 0th column. The index of 62 is so second row and the 0th column, right? And similarly, the index of 67 is, so first row, sorry, 0th row, the first column, and the index of 87 is first row, first column, and index of 33 is here the second row and the first column. Similarly, the index of 22, it is 0th row, second column, and then so index of 51 is first row, second column, index of 77 is second row and the second column. Similarly, with respect to the 55, the index of 55 in the memory will be like 0th row and the third column, and the 94 is the first row and the third column, and the 72 is the second row and the third column. See, what matters is how we are going to display the elements matters a lot. So, I am displaying the elements row wise. First, I will print 45 with the index as 0, 0. The next element to be displayed is 13. 13, what is the index here? First row and the 0th column. You can see like here, the column is fixed here, whereas row I am changing. Right, here also the column is fixed here. When I am printing the second row of the transpose matrix, the column index is fixed. I am changing the row index 0, 1 and 2. These index are with respect to the actual original memory. Original memory, how exactly the matrix is placed. So, based on this fashion, I am supposed to print the elements of the matrix there. So, here I should keep the row constant, I should vary the column. So, that is when I is equal to 0, so here I should print, so the 0th column elements 0, So 0 0 here column and row is varying here, right. So when I is equal to 1, I should print the first column elements in the second row. When I is equal to 2, I should print the second column elements in the third row. Similarly, when I is equal to 3, I should print the third column elements in the last row. That's how I can get the transpose of a matrix there. Now the simple code, what modification we can do here is, now look at this particular code. This is the normal method of printing the elements. I is less than m, I plus plus, j less than n, j plus plus. M and n are the order of the matrix. So in this particular example, the number of rows m is equal to 3 and number of columns n is equal to 4. So here I have, this is the 3 cross 4 matrix what I have taken into example. Now when I am displaying the normal matrix, when I is equal to 0, 0th row elements will be printed. So this index of these elements will be 0 0, 0 1, 0 2, 0 3, 1 0, 1 1, 1 2, 1 3, 2 0, 2 1, 2 2, 2 3. This is the normal way how I am going to print the elements. That's the way how exactly I am printing the elements with respect to this looping. But when I am printing the transpose of a matrix here, these conditions you must keep in mind. So here I am using the condition here I less than n. When I use the I less than n, n is the number of columns. N is the number of columns, and here I use the statement as j less than m. So m is the number of rows here. And when I am printing the elements here, I use the statement as a of ji. The reason why I am printing the ji is, so I should keep the column constant and I should vary the j here. We can note that when I am printing 45 here, so this is I and this is the, so this is particular thing is I value and this is the j value. When j is 0 and I is 0, I will print this particular thing. Again, keeping the I constant, when I vary the j there, 1 0. So that is the next element to be printed over there. And again when I vary this j becomes 2 and I remains as a 0. Fine. So I should keep this I particular index the constant here, because I is the first loop and j is the second loop. In the second loop, when j will run from 0 to m, so all the actual rows element of the original matrix will be printed. Fine. So that has to be printed in a column A, because row has to be converted into column and column has to be converted into rows to get the transpose of a matrix. So this is the change what we are supposed to do when I am printing the transpose of the matrix here. So with this particular program, when it is executed, so if we take the order of the matrix as 2 and 3 and 6 elements of the matrix, so I am reading it as 22, 7, 4, 84, 5 and 13. Then here, since we have the 2 rows, each row is having 3 elements, 22, 7, 4 will be the first row elements and 84, 5, 13 will be the second row elements. When I get the transpose here, it is like the 22, 7, 4 will come in the first 0th column and 84, 5, 13 will come in the second column there. This is the first column element, this is the second column elements. We can see like the row is converted into column and the columns are converted into the rows over there. Fine. So this is the way how exactly transpose of a matrix is printed there. So here this particular modification you should keep in mind. So since I am printing, I am varying the column there, so I should be taken as here the loop correspond to the column and here j loop correspond to the row here. So here what I am varying is j. So j I am varying with first subscript I am varying. If I am varying the first subscript, I am varying the row size, keeping the column constant. First I print all the rows elements which are supposed to get in the transpose first. This confusions we arise only because the storing is different and how we are retrieving the data is different. Say for example, if I am holding a pen, so whether I holding a pen in a reverse way or in a straight way or horizontally or vertically, so that matters to me. But the thing is, actually the pen remains pen only. So if I reverse the pen does not reverse internally. But so the same way here in the memory, what happens is elements will be stored so in the normal fashion, that is in the row wise. But here when I am printing the elements, here logically I should read the data in a different way, in such a way that I get the transpose of a matrix here. So here I keep the column constant and I vary the rows here to get the transpose of a matrix, and this particular index is doing that operation, right, keeping the row constant and varying the column. So here with this we can notice that I am keeping the row column constant. Row constant means when I is equal to 0, I print all the elements of the row 0 first. When I is equal to 1, I print all the elements of the first row. When I is equal to 2, I print all the elements of the second row, and so on, because I is keeping constant there and j is running inside this particular loop. But here what is happening is, so I is kept constant, because I is the first outer loop, j is the inner loop. The j will run first when I is equal to 0, and j will run to 0 to m is the number of rows. So now, so 0, 1, 2, 3 up to m minus 1 are the index for the j, and when I is equal to 0 with respect to this particular index, so when I is 0, here I will be printing 0, 0, 1, 0 and 2, 0, varying the elements of the row subscript. Fine. So then keeping the column constant there. So this is the way how I am going to print the transpose of a matrix. Now, so there are two concepts how exactly the arrays are stored in the memory. So that is a row major and the column major orders. The row major and the column major basically specifies the method of arranging the elements of the multi-dimensional arrays in a linear storage. Ultimately, the arrays should be stored in a linear fashion, that is in a continuous memory area. But how exactly I am storing? Whether I am storing row wise or the column wise matters a lot. If I am storing row wise, I call it as a row major, and if I am storing in a column wise, I am calling it as a column major order. Say for example, int a of 2, 3, I have 2 rows and 3 columns. Here we have, so in each row 3 elements. So 11, 21, 34 correspond to the first row elements, 14, 55, 62 correspond to the second row elements. Normally in programming with respect to C language, which supports row major ordering of the elements, so here how exactly we store the elements is a of 0, 0, a of 0, 1, a of 0, 2. So all the elements of the 0th row will be listed first, immediately followed by the next row, a of 1, 0, a of 1, 1, a of 1, 2. In case if there are few more rows in the elements, then I will take it as a of 2, 0, a of 2, 1, a of 2, 2 and so on. So that is row wise the elements are stored here. So is the we can differentiate between the color of the rows what I have used here. So this is in a light color, whereas this is in a gray color. So here 11, 21, 34 the elements of the 0th row, 14, 55, 62 are the elements of the next row and so on. Since the elements are arranged in a row wise, so we call this as a row major ordering. So consecutive elements of the rows of the arrays are in continuous memory areas. This is what the meaning of row major ordering is. The elements of the rows are stored in a continuous memory area. First I print the elements of 0th row, next I print the elements of first row, next I print the elements of second row and so on. Row wise the elements are getting printed there. When the elements are printed row wise, we call this particular the order of printing as a row major order. Similarly, we have another type which is called as a column major order. Now, in case of column major order, so here we can see like, so if I am declaring it as 11, 21, 34, 14, 55, 62 are the elements of the matrix. I have here 2 rows and 3 columns. But in case if it is a column major, then as usual the way we have read so far, 11, 21, 34 will not be the elements of the 0th row. Rather, so first we have to mention the column elements here. So here a of 0, 0, a of 1, 0, 11, 21 are the elements of the first column, 34, 14 are the elements of the second column, 55, 62 are the elements of the third column. So that is the index will vary. You can see that a of 0, 0, a of 1, 0, row column is kept constant, row is varying here. Here also after printing the elements of the first column, that is 11 and 21, we go for the next elements 34 and 14, and then we go for the next column elements, that is 55 and 62 there. So this is the way how exactly I am going to store the elements in the column major order. Fine. So in this particular case, the consecutive elements of the columns of the array are in a continuous memory area. Column wise, since I am storing the elements there, so I call this particular this way of ordering of elements as a column major orders. So though I am storing it in a column wise, but the elements of the matrix remains as 11, 21, 34 are the 0th row elements, 14, 55 and 62 are the second row elements. Only thing is I am storing the elements here column wise, right. So you can say like a of 0th row, 0th column is 11, and here first row and 0th column, the first row here the value is 21, the way how exactly it is getting stored over there. So but the thing is, when you are reading the elements here in a row wise only, we will read it. So but basically the C language supports only the row major ordering of the elements. Basically the column major is supported in some languages like Fortran. So now if you want to read the elements of the matrix in row major order, then so far what you did, the reading of the matrix elements, so that is nothing but the row major ordering only. So this is I specifies the row and j specifies the column there. So here I am reading the elements in the normal method. So I is less than m, this is the specify the row size there, j less than n condition specifies the column size here. So with this I will be reading the elements of the matrix. Now when I am printing the elements there, I can use the same printf statements here. So to print the elements in a row major order, but I am going to print the elements in the column major order. So, before we see that, let us see the output here. This is a normal method of reading a matrix and printing a matrix. I am mentioning here the order of the matrix as 2 and 3. So, 6 elements I am entering here. The 6 elements of the matrix I am displaying it as 22, 7, 4, 84, 5 and 13 as the elements of the matrix there. Now, if I am using the column major order, then here you must specify how I am going to read the elements. So, I is equal to 0, I less than n I plus plus, j is equal to 0, j less than m j plus plus, scan of percentage d and a of j I. So, column wise I supposed to read the elements, means I supposed to read the element as a of 0 0, a of 1 0, a of 2 0, a of 3 0, like that. That is keeping the column constant, varying the rows, I supposed to read the elements of the column first. So, that is, so when I is equal to 0, I will run from 0 to n minus 1, where n is the column size, whereas j is the row size there. So, here we can see that j is varying. This is similar to the way what we have did in case of a transpose of a matrix. So, the row will vary, whereas a column we are keeping it in constant. If we read the elements there, fine. So, first we read, say for example, when I is equal to 0, j is equal to 0. So, we read the 0 0 first element. Then when j will run to next iteration, j becomes 1. When j becomes 1, we will be reading 1 0. 1 0 means 0th particular column, the second element what is there. So, that we are going to read. Again when j becomes 3, third row 0th column. So, that is the way how exactly we are reading the elements over there. So, fine. Now, and to display the elements, normally I can display like I is equal to 0, I less than m I plus plus, j is equal to 0, j less than m j plus plus, scan of print of percentage d a of I. This printing is normal. Only thing is reading of the elements I am reading in the form of the column major order, fine. So, basically the C supports the row major order. The way how I am printing the elements here, same way if I am reading the element, that is that goes better with respect to the C language, because C supports row major ordering. In case if I want to read the elements in the form of a column major ordering, I should do the changes in the looping constructor. I less than n I should use here, n is the row size, and j less than m I supposed to use here, j is the row size, and here I should read it as ampersand of a of j I. This is the way how exactly I did in transpose of a matrix. The row and column will vary here. So, here, so I will be reading the elements in the form of column major, whereas printing is done normally. So, say for example, the output of this particular code. So, enter the order of the matrix. I am entering here 2 and 3. The 2 cross 3 is the order of the matrix here. 6 elements will be there. The 6 elements of the matrix I am entering as 22, 7, 4, 84, 5 and 13. And here you can note that, so we am entering the elements as 22, 7, 4. The entries what we have done is 22, 7, 4 and then 84, 5 and 13. Now, it is not like, so 22, 4, 5 are the elements of the 0th row, 84, 5, 13 are the elements of the second row. Rather, so the way how we are entering is column wise. The column wise means here how many columns are mentioned here? The order of the matrix we mentioned it as a 2 cross 3. 2 cross means 2 is the row size, whereas 3 is the column size. Since we have in each particular row the 3 columns, number of rows present there is a 2, whereas number of columns present is a 3 over there, right. So, it is like 2 rows and the 3 columns, and when since we have the 3 columns there, the elements what is 22 and 7 what is there. So, this is the index of 0th row and 0th column, and this is the index of first row and 0th column. This is the index of, so here, so first I read the elements of the 0th column. So, next I read the elements of the first column. To its next, I will read the elements of the second column. This is the way. So, keeping the row column constant, row I am varying in each of these particular situations. So, here, so this is 0th row, 0th column. Then the 0th row, first column element is 4. Then, so 2 rows and 3 columns are the 0th row, and the second column element is 5. And then, so first row 0th column element is 7. So, first row first column element is 84 and first row second column element is 13. So, while printing I print in normal way 22, 4, 5, 7, 84, 13. But while reading I should do the modifications. So, while entering the data also I should see to it that column wise only I supposed to enter the data. So, we have to make a note here like in column major order we must input the elements column wise. So, this is mandate when you are using the column major order of the elements. So, fine. So, we will stop here. In the next session we will see. So, a lab program, what is there, the reading of the matrix and performing the multiplication over the matrices. So, fine. Thank you.